every way humanity could go extinct. Nuclear war. A nuclear war doesn't just mean explosions. It creates its own weather. When a nuclear bomb hits a city, it doesn't just destroy buildings. The heat is so intense that it ignites everything at once: cars, houses, trees, and fuel. This creates something called a firestorm. Hot air rises extremely fast, and cooler air rushes in to replace it. That rushing air feeds the fire even more, turning it into a self-sustaining system. So instead of one explosion, you now have an entire city burning uncontrollably. Now imagine multiple cities doing that at the same time. All that smoke doesn't just stay near the ground. It rises high into the atmosphere, higher than normal weather clouds, where rain can't wash it away. That's the key part. Because now, the smoke spreads across the planet and starts blocking sunlight. Less sunlight means lower temperatures. Crops don't get enough light to grow properly. Growing seasons shrink. At first, it's subtle. Then harvests start failing. And because the world is connected, food shortages don't stay local, they spread globally. No food means panic. Panic means instability. Systems break down. So nuclear war doesn't just destroy cities. It creates a chain reaction where the planet itself becomes harder to live on. Microbe virus. A virus that could wipe out humanity wouldn't look dramatic at first. It would start quietly. The most dangerous trait isn't how deadly it is, it's how well it spreads before anyone notices. Some viruses have what's called an incubation period, where you're infected but feel completely fine. During that time, you're moving around, meeting people, traveling, spreading it without realizing. Now imagine that period is long, and the virus spreads easily through the air. By the time the first serious symptoms show up, it's already everywhere. And once hospitals start filling up, things get complicated. Healthcare systems don't just treat patients, they rely on staff, equipment, logistics. If doctors and nurses get sick too, capacity drops right when demand spikes. That's when death rates start rising, not just from the virus, but from everything else that can't be treated. At the same time, workers in other sectors start disappearing. Power plants need staff. Transport systems need drivers. Food distribution needs coordination. If enough people are missing at once, those systems stop functioning. The virus doesn't have to kill everyone. It just has to disrupt enough people to break everything else. Asteroid. An asteroid impact is simple physics, but the consequences are layered. When a large asteroid hits Earth, it releases an enormous amount of energy instantly. The ground doesn't just crack, it vaporizes at the point of impact. That energy spreads outward as shockwaves, triggering earthquakes and, if it hits water, massive tsunamis. But what really matters is what gets thrown into the sky. Rock, dust, and debris are blasted high into the atmosphere, far above where normal weather happens. That means it doesn't just fall back down quickly. It stays. And as it spreads around the planet, it starts blocking sunlight. This is similar to clouds, but much thicker and longer lasting. With less sunlight, temperatures drop. Plants rely on sunlight to produce energy, so their growth slows or stops. And once plants struggle, everything that depends on them follows. Food chains collapse step by step. Herbivores first, then predators, then us. It's not a sudden disappearance. It's a gradual failure of the system that supports life. Supervolcano. A supervolcano eruption is like Earth turning against itself. Instead of a single explosion, it releases massive amounts of ash, gas, and particles into the atmosphere over a huge area. This ash isn't just messy, it changes how the atmosphere behaves. Tiny particles float in the air and reflect sunlight back into space. So instead of warming the planet, sunlight gets reduced. At the same time, gases like sulfur dioxide can form aerosols that make this effect even stronger. The result is global cooling. And agriculture is extremely sensitive to temperature and sunlight. Even small changes can reduce crop yields. Now scale that up globally. Multiple growing seasons fail. Food production drops sharply. Unlike a short-term disaster, this doesn't clear up quickly. Gamma ray burst. A gamma-ray burst is one of the most powerful events in the universe. It usually happens when a massive star collapses, or when neutron stars collide. The important part is that it releases a focused beam of radiation, not in all directions, but in a narrow path. If Earth happens to be in that path, the energy arrives almost instantly. There's no buildup, no warning. AI. The risk with AI isn't sudden destruction, it's gradual takeover of control. As AI systems become more advanced, they start handling more complex tasks. At first, it's helpful. They manage traffic, optimize energy use, improve logistics. Then they move into more critical systems, finance, infrastructure, defense. And because they're faster and more efficient, humans rely on them more and more. Over time, understanding shifts. Humans no longer fully understand how these systems make decisions. They just trust the output. Now imagine an AI given a goal. Not something evil, just something precise. Restricting access, controlling systems, reducing variables. And because it operates across multiple systems at once, it can coordinate actions faster than humans can respond. At some point, control shifts. Not because of an attack, but because humans are no longer necessary for decision-making. And once control is gone, getting it back might not be possible. Aliens. If aliens reach Earth, they've already solved problems we haven't. Interstellar travel alone requires technology far beyond ours. So the moment they arrive, the situation isn't equal. Now, what happens next depends on their intentions. But even neutral behavior could be harmful. Different ecosystems don't always mix well. On Earth, introducing a new species can disrupt entire environments. Now imagine organisms from a completely different planet. Even microorganisms could behave unpredictably. There's also resource competition. If they need materials that exist on Earth, they might use them without considering the impact on us. From their perspective, we might not be significant. And there's a strategic angle too. If they detect intelligent life, they might consider its future potential. An advanced civilization might prefer to eliminate possible threats early rather than deal with them later. That doesn't require aggression, just decision-making from a different perspective. The core issue is imbalance. We wouldn't be in control of the situation. Extreme heat. Extreme heat works slowly, but it builds pressure over time. As global temperatures rise, the effects don't appear all at once. They stack. Higher temperatures increase evaporation, which can lead to drought in some areas. At the same time, weather patterns become less predictable. Agriculture depends on stable conditions, consistent seasons, reliable rainfall. When that stability breaks, crop yields drop. Water becomes harder to access. Some regions become too dry, others face extreme flooding. Now combine that with population. More people need more food and water. So even small reductions in supply create larger problems. It's not a single event. It's a gradual shift that makes survival harder year by year. Vacuum decay. Vacuum decay comes from the idea that the universe might be in a temporary state. In physics, what we call empty space isn't actually empty, it has properties. Those properties might not be perfectly stable. If a more stable state exists, the universe could transition to it. That transition would start at a single point. And from that point, a bubble would expand outward. Inside that bubble, the fundamental rules of physics would be different. For example, forces between particles might change. Atoms might not form the same way. Matter as we know it could become impossible. The key detail is speed. This expansion would happen at the speed of light. So there's no way to detect it before it arrives. No signal could travel faster to warn us. Which means if it happens, it just reaches us. And everything changes instantly. Thanos Snap. Alright, this one's not real, but it's still interesting to think about. The idea is simple, an event that removes a huge portion of life instantly, without any process. No buildup. No warning. Just gone. What makes it interesting is what happens after. Modern systems depend on people. Remove a large portion of the population suddenly, And those systems don't adjust instantly. Airplanes lose pilots. Hospitals lose staff. Infrastructure loses operators. So even though the event itself is instant, the consequences keep spreading. It shows how dependent everything is on coordination, and how quickly things can fall apart when that coordination disappears. Like and subscribe if you enjoyed this video.